Hey guys, and welcome to another A-Level Maths revision video. In this video today, we're going to take a look at exam questions for differentiation from first principles. Now, the questions you're going to see in this video are typically seen more on the AS paper rather than the A2 paper. However, you do need to be confident with differentiation from first principles, because in second year you'll come across it with trig functions. Okay, so let's just take a look at these questions here. There's only two, but hopefully they won't be too bad. Now here, this question is taken from the May 2018 AS paper 1, and we want to prove from first principles that the derivative of x cubed is 3x squared. Now here, we're going to be using first principles, so we need the formula for first principles, and this is given in your formula book, so you don't need to worry about memorizing this result. So using the formula book here, f prime of x is simply given here as the limit as h tends to 0 of f of x plus h minus f of x all over h here. Okay, and this formula might look complicated, but it is simply just giving us the change in y over the change in x. Okay, the change in x simplifies to just give us x, okay, because it's x plus h minus x, so it just gives us h there. Okay, now here, in the context of this one, as we've got the function x cubed, so f of x here, so f of x is simply x cubed. In that case then, applying this here, using this formula, we're taking the limit as h tends to 0 of f of x plus h, so that's going to be x plus h cubed here, x plus h cubed, minus f of x, so f of x is x cubed, so minus x cubed, and this is all over h. Okay, now here, as we've got this cubic expression here, x plus h cubed, we can just use binomial expansion here. Okay, so x plus h cubed, just use binomial expansion. You can, if you want, expand this bracket 3 times. You can do that, it's just a bit long. I'd just use the binomial expansion here, but there's nothing wrong with doing that method as well. So in this case, we take the limit here as h tends to 0. Now in this case then, using the binomial expansion, we get x cubed plus 3x squared h plus 3x h squared, so 3x h squared, and finally plus h cubed there. Okay, and don't forget our f of x here, this minus x cubed. Now this is all over h still. Okay, now here, what I want to do is start simplifying the numerator by collecting the like terms. So here, we're still taking the limit as h tends to 0. Well, x cubed minus x cubed, they'll cancel. And at that point there, we can't actually simplify anything further. The only thing we can actually do now, so if we just write this expression out here, just so we've got it, this is 3x squared h plus 3x h squared plus h cubed, and this is all over h. Now at this point here, to simplify, the only thing we can actually do now is divide the numerator and denominator here by h. Okay, so we'd lose that h there, we lose the h in our denominator. This 2 here would become a 1, so that would just give us 3xh, and this power of 3 here would simply give us a 2 there. Okay, so I should write it there like that. So that's h squared. So in that case, this is the limit as h tends to 0 for 3x squared plus 3xh plus h squared there. Okay, and all we need to do here now is just consider the behaviour of this limit. So as the limit here as h tends to 0 of this expression, well, 3xh would just tend to 0, h squared will also tend to 0, so this part here, this tends to 0, this part here tends to 0, and I just get left with 3x squared. So that just simply gives us 3x squared, which is exactly what we wanted to show. Okay, so that gives us 3x squared as required there. Okay, so that gives us the solution to our first question. And finally, let's just take a look at one more question then. Like you can see, these questions are very kind of mechanical in nature. You'll never get kind of thrown any tricks essentially with these. Okay, at most, all you'll need to do is a lot of expansion or binomial expansion. That's about it. So here, what we want to do is prove again from first principles that the derivative of 3x squared is 6x. And again, all I'm going to do is give the formula for first principles. So here we want f prime of x, and this is equal now to the limit as h tends to 0 of f of x plus h minus f of x all over h. And again, remember, this is given in the formula book. And applying that here, where f of x is 3x squared, in that case, we write this as the limit as h tends to 0 of f of x plus h, that's 3x. So let's write that. So that's 3 lots of x plus h squared. So we can see it clearly here. Minus f of x, which is minus 3x squared. And again, this is all over h. Now here, again, all I'm going to do is expand this double bracket here. This is simply double bracket, so again, you can use binomial expansion if you want, but simply as this is 2 brackets, we can just expand it in the normal way. So this gives us the limit as h tends to 0 of 3 lots of x squared plus 2xh, so 2xh, finally plus h squared there. Okay, we've still got minus 3x squared there, and this is all over h. So here, I'm going to expand this bracket here with this 3 on the outside. This gives us the limit as h tends to 0 of 3x squared plus 6xh plus 3h squared there. Okay, we've still got a minus 3x squared at the very end, but what we can notice here is this 3x squared, we've got a minus 3x squared here, they will just cancel to give us 0. So they cancel there. And what I get left with then is this 6xh plus 3h squared. Okay, this is still all over h though, so don't forget your h. Okay, so in this case now, again, just like we did with the previous question, we're going to divide numerator and denominator here by h. So in that case, the h in the denominator will disappear, this h here will disappear, and this h squared becomes h to the 1. So in that case now, what I've got is the limit as h tends to 0 of 6x plus 3h. Okay, so 6x plus 3h. And then in that case, again, considering the behavior of this expression here, with this limit, what I get then is this 3h, this tends to 0, so I just get left with 6x then, okay, which is exactly what we wanted to show there. So that gives us 6x as required there. Okay, so that's both of the questions answered there, and hopefully this topic doesn't seem too bad. Like always, if there's any issues, please just leave a comment down below, but other than that, hopefully that's helped.